Hey folks, and welcome back. Today we're going to be taking a look at how do we calculate speed and velocity, and we're going to be looking at how do we do calculations not only of just speed and velocity, but for all of the different variables in our speed and velocity equations. So up here at the top of our document, and if you don't have this open already, make sure that you go ahead and get that opened up. We've got our speed equation and our velocity equation. And one of the things you should immediately notice is that the structure of these equations is basically the same, right? We have speed and we have velocity being equal to either distance over time or displacement over time. And so when we're doing these equations, what I'm going to be showing you all in terms of the general structure for how to solve them can be applied to either one of them. And so basically what we're doing here is using some simple algebra skills, and we're going to be using these skills to solve our equations. So these are going to be word problems. They're going to be about one or two sentences. And I know that word problems are sometimes a little tricky to deal with. So I'm going to show you all a technique for dealing with these word problems and getting the information correct. All right. So the first thing we need to do is we need to read the problem, and you need to read the whole problem. If you only read one part of the problem, you're likely to miss a key and important information, like some of you all did with the distance and displacement activity, missing that you walked home at the end of that. So in our first question, let's read the whole thing. What is the average speed of a cheetah that sprints 100 meters in 4 seconds? Okay. There are three things that we need to figure out because there are three parts to our speed equation: speed, distance, and time. The question is asking, what is the average speed? So that means that we don't know the speed. So what we're going to do is we're going to rewrite this basic formula, but we're going to be subbing in the things that we know. So speed, I'm going to abbreviate as S, okay, because we don't know it. It's our variable, is equal, okay? We have a cheetah that sprints 100 meters. This is our distance, and I would recommend that you go ahead and put a D as you're reading through the question, right? So 100 meters, that's their distance in 4 seconds. That's our time, okay? So speed is equal to distance divided by time. But we know the distance, we're given that, so we're going to substitute in 100, and then don't forget the units, meters. And then that is divided by our time, which is 4 seconds, okay? So this is how we're going to set up our equation. Again, we're taking this general equation up here, which is that speed is equal to distance divided by time, and we're just substituting in from the problem the things that we know. And then the final skill that we need to be able to do is we need to actually be able to solve the problem. So we have 100 meters divided by 4 seconds. That's equal. So this is all pretty straightforward. We just get 25 meters per second, which is very, very fast. But this is a cheetah we're talking about. And so this is our answer. Don't forget that because this is speed we're talking about, we don't have to include a direction, but we do need to make sure to include a unit in order to get full credit. Now, anytime that you are given a question where you're asking to find the speed, like in number 2, those questions are all going to be very similar. They're all going to solve the same way. So anytime you're asked to find speed, you can set it up like you have it set up here, and you will get the answer correct because the general formula does not change, right? Okay, so that's how we would find speed. And again, you can use that for finding velocity as well because the equation is set up the same way. Let's take a look at a different kind of problem. Let's take a look at one where it's asking, what is his time? Again, in this equation, we are given speed. So if we just kind of read through, Connor runs the 100-meter dash. Okay, 100 meters, that's our distance, with an average speed of 8.2 meters per second. What is his time? So we don't know the time. Now let's just rewrite our general equation real quick, since we don't have it on this page. Speed is equal to distance divided by time. Okay, so what are the things that we already know? Well, we know the distance, we know the speed, but we don't know the time. So what is our speed? Our speed is 8.2 meters per second. That's equal to our distance, 100 meters, divided by our time, which is what we don't know. Let me rewrite that T. There we go. Okay, so this is the one that's the trickiest to solve because it's a two-step excuse me, solving process. The first step is that we need to get T on the opposite side of the equation. And that's because T is right now divided into 100. Whenever we're solving an equation, remember, we need our variable, the thing that we don't know, on the side by itself. And we need it to be in the numerator, not in the denominator, which is where T is right now. So to get T to the opposite side of the equation, we're going to multiply by T on both sides of the equation. Okay. Now, when we do this, because T is in the denominator here, these are going to cancel out. And so we're left with T times 8.2 meters per second is equal to 100 meters. So let me rewrite that so it's a little bit cleaner. We have T times 8.2 meters per second is equal to 100 meters. Okay. So what's our next step? Well, again, we want to try to get T by itself. So here's step number 2. Step number 2 is we're going to divide the left side of the equation by the 8.2 meters per second. We're going to divide it by speed. So that cancels out. And we're going to need to make sure that we do that on the other side of the equation as well. So what are we left with? Let's rewrite this again. T is equal to 100 meters divided by 8.2 meters per second. Okay, so we've gone through, we've rearranged the equation so that now that T is equal to our numbers, right? Just like it was with the speed equation. So we're basically just trying to rearrange it so that we have our variable equal to the other numbers. And so now we can use our calculator and figure this out. Our time, if we take 100 and divide it by 8.2, is going to be equal to 12.19 seconds. And we need to make sure that we're including this unit. How are we only left with seconds? Well, if we think about this, we've got meters divided by meters. So these meters cancel out. And so we're just left with the seconds here. And that's how we end up with 12.19 seconds as our answer. Again, anytime as you're solving for time, whether that's in the speed equation or in the velocity equation, you can use this setup and you will come up with the right answer, right? Again, we're just rearranging the equation so that time is equal to our two other variables in the correct position. Oftentimes what will happen is that people will flip these. That's why I recommend that you go through this process so that way you always get it right. Okay? All right, so that's how we solve for time. Let's look at one final example. Let's figure out how do we find the distance. So a car moved at an average speed of 60 kilometers per hour. That's our speed. At this rate, how far, that's our distance, did it travel in 4 hours? So in this equation, we're given the speed and the time. We're trying to find the distance. So again, let's start with our general equation, our general formula. Speed is equal to distance divided by time. Okay, so what are the things we know? Well, we know the speed. So our speed is 60. And again, let's keep the units, kilometers per hour. That is equal to our distance, which we don't know, divided by our time, 4 hours. Okay, so in this equation, again, we're starting off with the distance on, not by itself, right? It's distance divided by 4 hours. So we need to go through and move the 4 hours to the other side. So we're just distance by itself. So notice I'm still multiplying by time first. Okay. But this time, because I want to find distance, this is just a one-step problem. So I just need to multiply by 4 hours on both sides of the equation. Okay. When that happens, this cancels out. And so if I rewrite this, I now have 4 hours times 60 kilometers per hour is equal to my distance. And so now distance is just equal to 4 times 60. And so my distance is going to be equal to 240. And I need my units. Well, notice that the hours are on top for the 4, but on the 60 that they're on the bottom. And so these will actually cancel out. And that will leave us with just kilometers. So our final answer is 240 kilometers. And again, when you're doing these when you're doing these questions, whether you're trying to solve for distance or displacement, okay, this is going to work exactly the same way. All right. You are going to set up the equations and solve the equations the exact same way because, again, the speed and velocity ones are the same. And every time you use the speed equations, you're using the same formula. So the way that you set it up and execute it is going to be the same. Okay. So finish the rest of this assignment and then submit it. If you have questions or need help, please do reach out. I'm here to help. I hope that you all have a wonderful day, and I'll see you soon.